Hello everybody, thank you for watching. This is our 7.12 video on the molecular formula. In this video, you'll learn how to write molecular formulas from our empirical formulas. What are molecular formulas? So molecular formulas are just whole number multiple of the empirical formula. So for example, if we have an empirical formula, we know that that's the simplest ratio of all the elements. So here we have an example, H2SO4. An example of the molecular formula would be if we take our empirical formula and multiply each of those subscripts by 2, we would have a whole number multiple of the empirical formula. So here's an example of when we take the empirical formula and multiply it by 2, we have H4S2O8. And you can see that it's not the simplest form because we multiplied it by 2, therefore it's a molecular formula and not an empirical formula. Another example would be if we take it and multiply each subscript by 4. Therefore, then we have another example of a molecular formula because we know that they are whole number multiples of the empirical formula. So know the difference between an empirical formula and a molecular formula. Let's talk about the steps in finding molecular formula. So the first thing you want to do is when given your empirical formula, you want to figure out what the molar mass is for that empirical formula. Then we have a formula. It says to divide the molecular mass that is always going to be given to you in the problem by the empirical formula molar mass. So one thing I like to do is I like to remember the mnemonic me as in M-E. Therefore, I always know that the molecular molar mass always goes at the top and then the empirical formula mass always goes at the bottom. When you divide them, you're going to get a whole number. Lastly, what you're going to do is you're going to multiply the empirical formula by the whole number that you get from this division problem, and you're going to multiply each subscript by that whole number in order to finally get your molecular formula. Let's look at an example problem. In example number 1, it says the empirical formula of a compound of phosphorus and oxygen was found to be P2O5. Experimentation shows that the molar mass of the compound is 283.89 grams per mole. What is the compound's molecular formula? So what you want to do is you want to take a look at the steps for molecular formula. First, you want to determine the empirical formula molar mass. So here, it gives you the empirical formula. When you calculate for the molar mass, you're going to find that P2O5 has a molar mass of 141.943 grams per every 1 mole. Then, you want to divide the molecular mass that's given to you in the problem, which is right over here, by the empirical formula molar mass. So the empirical formula molar mass goes over here. This molar mass that's always going to be given to you in the problem goes at the top, and then you just want to divide in order to get a whole number. Here you're going to get a whole number of 2. The last step says multiply the empirical formula subscripts by the whole number to get your molecular formula. So our whole number is 2. We're going to take our empirical formula and we're going to multiply each of these subscripts by 2 in order to get our final molecular formula of P4O10. Again, notice the difference between an empirical formula and a molecular formula. An empirical formula is the simplest ratio that you can't divide these any further, while the molecular formula is a whole number multiple. Let's try another problem. Here we have a sample of a compound that contains 140.1% of nitrogen and 80% of oxygen. And it has a molar mass of 220.1 grams per mole. Calculate the empirical formula and molecular formula. So here we have a problem. We're starting with the percentages of each of these elements. First, we need to calculate for our empirical formula by following these steps, and then once we get our empirical formula, we can then go ahead and find our molecular formula. So let's go ahead and figure out our empirical formula. We always remember the first step is percent to mass. So because we always assume we have 100 grams of each sample, we can just change the percentage signs to grams. Then you want to change mass to mole. So each of these you need the molar mass, and you're going to see that the molar mass is going to cancel, and you're going to get two numbers in moles. Then you want to divide by small. So the smallest number here is 5.00 mole. When you divide that, you're going to see you're going to get 2 and 1. Then if you need to, you want to multiply till whole. In this case, we don't have to, so therefore we can just use our subscripts for our empirical formula. Once we find our empirical formula, we now need to figure out our molecular formula. Therefore, we need to follow these steps. First, you want to figure out the empirical formula molar mass. When you do that, you can see that for N2O, our molecular molar mass for our empirical formula is going to be 44.013 grams per mole. You want to replace that in this formula over here. Now, our molecular molar mass is always given in the problem. Here, it says the molar mass of 220.1 grams per mole is the molar mass. This is always going to be our molecular molar mass. So we can go ahead and replace that number. When you do the division, you can see the whole number that we get is 5. The last step says multiply the empirical formula subscripts by the whole number to get the molecular formula. So here, since we have a whole number of 5, we're going to multiply our empirical formula, each of the subscripts, by 5 in order to get our final molecular formula of N10O5. What I want you to do now is try this U-try problem where it's going to ask you to first calculate your empirical formula and then calculate your molecular formula. And check back in to make sure you get your answer correct. Your empirical formula should have been CR2O3, and then your whole number multiple that you're going to multiply is 4 in order to get our molecular formula of CR8O12. And that concludes our video for today. Thank you for watching.